So today we're talking about mobile Linux and MacOS operating systems, and we'll go into some of the differentiation between them. We'll talk about the purpose and characteristics of mobile operating systems, which should be kind of a no-brainer. We'll be comparing Android and iOS operating systems. We'll talk about the features of both and you know, some of the things that are common amongst all of the mobile devices. Then we'll talk about securing our mobile devices, some things that we can do to make them a little bit more secure, which is a good thing. Which will, you know, that'll also include our logins, whether or not we're doing remote wipes, our two-factor authentication if we're using that. And then we'll talk about the Linux and Mac operating systems, and we'll talk about some of the tools and features between the two of them, some of the best practices, some of the CLI commands, and then we'll talk about troubleshooting. Then we'll go over our 6-step troubleshooting chart. So with mobile operating systems, oh, can you guys hear me okay?
Yeah, I can hear you.
Okay, wonderful. So with mobile operating systems, we've got a couple of different things here. We've got open source and closed source. So we really should kind of discuss that before we get into anything else. Open source basically means that the users can analyze and modify the software. In order to do that, you need to be able to see the source code, the actual code that creates the software. And with Android, you're allowed to do that. iOS, not so much. iOS would be closed source. So when a developer chooses to provide the source code, the software is said to be open source. And that basically means that it can be modified, it can be looked at and reviewed. And that's a good thing, because when you have an open source operating system, that means that if there are bugs in it, perhaps another programmer somewhere else will find a bug that you overlooked. Or perhaps someone else will add a module to that operating system that can be used throughout the community. So that's a good thing. If the program's source code isn't published, then the software is said to be closed source, and that means that you cannot look at it, you can't make changes to it, you can't debug it. So Android, of course, is developed by Google, and iOS is developed by Apple. And so we've got some applications and content sources. So mobile devices, of course, come with a number of different apps pre-installed to provide your basic functionality. And, you know, we're talking about email, music, pictures, video games. Some of those apps can be downloaded from a content source. So apps for Apple iOS mobile devices are available for free or purchase from the App Store. Apple uses a walled garden model for their apps, meaning that the apps have to be submitted to them and approved by Apple before they can be released to any users. And this prevents the spread of malware and malicious code, and it gives the Apple community or the Apple business model more total control over any problems that might arise. Android apps, on the other hand, are available from Google Play and third-party sites like Amazon's App Store. Android apps run in a sandbox and have only the privileges enabled by the user. So when you add an application, make sure that you look and see what it's actually going to be accessing, because that's where a lot of your security issues are going to be. There's a lot of times there's no reason for an app to have location services or to be able to access your pictures and everything else. So you really do need to read that and user license agreement for that. They can be installed using an Android application package file. And basically users can directly install apps without going through the storefront. So in other words, I could download an app and put it on my laptop, and then I could connect my laptop to my phone and sideload it into my phone, as opposed to doing it directly from the source. So some of the common things that we have on our home screen items, in our Android main home screen, we've got Navigation icons, our system bar lets us go back home, view our recent apps, see the menu. We may have some shortcuts to other apps up there. Every Android device. For our notification, our system icons, when notifications are open, you can respond to a notification by touching it. You can dismiss the notification by swiping it off the screen to the other side. You can dismiss all the notifications with the icon. And you can toggle some of your frequently used settings. You can adjust the brightness of the screen and of course open the settings menu with a quick settings icon. And I know probably some of this is you might already be very familiar with because you have an Android phone, but for those people who have iPhones, perhaps they're not as familiar. So this
I have an Android tablet.
Yeah, that's why we're going over both at the moment. For our home screen items, so there are some very important differences in the way the iOS interface works. There's no navigation icons. A physical button may have to be pressed instead of touching navigation icons. There's no widgets. There's only apps and other content that could be installed on an iOS device screen. There's no app shortcuts. Each app on this home screen is the actual app, not a shortcut. And unlike Android, iOS devices don't use navigation icons to perform the functions. Some common functions performed by the home button include waking the device, returning to the home screen, starting Siri or voice control. And we've got our iOS notification center. iOS devices have a notification center that, of course, is going to display all the alerts in one location, very similar to an Android. And it'll do that even while the device is locked. So from the commonly used settings, your user can toggle frequently used settings like airplane mode, Wi-Fi, Bluetooth, do not disturb, and screen location lock. I do kind of like that. I do like the iPhone's do not disturb. Sort of when it recognizes that you're in a car, when you put in your do not disturb because you're driving, it will say that you're driving for texting, which is kind of cool. So let's see. It's the same thing with the Android. We can fix our screen brightness. We control the music player.
Hey, Linda.
Yeah.
You might be having some issues because you're coming in garbled.
Oh, okay. Thank you.
I don't know if anybody else is hearing it.
Okay, thank you. Let me see what I can do to fix that. Okay, so let's see. We were talking about some of the things that you can do from the settings screen. You can access AirDrop, your flashlight, clock, calendar, and camera. There's iOS Spotlight, and that shows suggestions from other sources like the internet, iTunes, App Store, like movie times and nearby locations, those kind of things. For our orientation, there's a sensor inside the device known as an accelerometer, and basically it detects how it's being held, so it can change the orientation appropriately, go from portrait to landscape. And when the device is turned on to landscape mode, the camera app also turns to landscape mode. So some devices also have gyroscopes to provide more accurate movement readings. And those allow you to use it as a control mechanism for driving games where the device itself is acting like a steering wheel. For our calibration, so we've got, our main concern is brightness, right? When you're out in bright sunlight, it makes the screen really difficult to read. So it'll increase the brightness level. And the same is true for very low brightness. It's helpful when you're reading a book on a mobile device at night. It will raise the brightness level. So some mobile devices can be configured to auto adjust the brightness depending upon the amount of surrounding light, and it should have a light sensor in order to use auto brightness. For GPS, so our GPS receiver uses at least 4 satellites. to calculate its position based on messages. We can also use triangulation from cell phone towers as well. But our GPS service basically allows app vendors and websites to know the location of the device and offer location-specific services, which is called geo-tracking. I normally have my GPS turned off just because there's no reason to have geo-tracking enabled. So indoor positioning systems can determine the device location by triangulating its proximity to other radio signals like Wi-Fi access points. And so with that said, when we're talking about phone tracking, I don't know, you may have heard talk about COVID-19 tracking through your phone. And so they're talking about doing that, and it will be voluntary. And this will be done by Bluetooth. And basically it'll be Bluetooth pinging other devices to track movements and contacts. So for example, when you go to the grocery store, you don't know the people that are around you, right? So if you ended up positive and you went to the hospital and they said, well, who were you in contact with? The best you could say is, well, I went to this store at this time. Well, by the Bluetooth pinging, basically it's going to track your movements and your contacts. It'll be stored in your phone for X number of days, and then it'll be deleted. And so then if you end up positive, they can track who you've come into close proximity with. All those people that are in the store with you that you don't know. So that can be really helpful in this, under these circumstances. That said, probably, there we run into privacy issues. So this is going to be voluntary. But I think sometimes we do need to think about the overall benefit to society also. So, yeah.
Linda?
Yeah.
Yeah, when you have too many GPS features on your iPhone, for example, it can drain the battery very fast. So if you look at a YouTube video that shows you how to save battery power,
Mm-hmm.
it shows you exactly what to turn off, what features to turn off that you don't really need.
Right, and that's a really good thing. You should always, make sure that you research, what things are running all the time. And of course, all of our phones have battery saving mode, so which will also turn off all those things. So for conservation's sake. But thank you. So our lab is going to be mobile device features, and there's going to be Android and there's going to be iOS. So I'm going to, and you'll notice that I haven't posted any of the labs yet, but this one, it will require that you either have access to both devices, or that, I might, even if you have access to both devices, I might have you guys team up so that you do some teamwork. Group activities are not bad, so, or partner activities are not bad. So that's an idea. So Wi-Fi calling. So if there's, so instead of you using your cell carrier's network, you can use your Wi-Fi hotspot. And if by chance there's no hotspot within reach, the phone will use the cell carrier for your voice calls. Wi-Fi calling is really useful in areas with poor cell coverage because it's going to use your local Wi-Fi hotspot to fill in the gaps and make it so that you've got a nice, good audio signal. Our hotspot must be able to guarantee a throughput of at least one megabit per second for the to the internet for a good quality call. And we've got examples there on how to set that up. And then we've got near field communication payments. And so there's lots of different ways that we can do payments through our phone. Mobile payments refer to any payments that are made through a mobile phone. And these are just a few ways that you can make payments and transfer money. You can use your SMS-based transactional payments, direct mobile billing, and that's going to your cell phone bill. mobile web payments, so it uses a web or dedicated app. And of course, it's near field communication. So basically you can just hold your device close to a pay point or point of sale device, and it will pick up the signal. And there are some security ramifications to that as well. I personally would not enable NFC on my phone unless I was about to use it, and then when I was done, I would disable it. But I am a little bit more paranoid than most. So you can also set, do you remember when we talked about VPNs? So you can also set up VPNs through your phone. And that makes it so that you can connect to your business in a secure fashion through a VPN tunneling protocol. And they also allow for data encryption, so we've got a nice secure connection.
Gotta go.
Okay, go have fun.
Okay, joys to the world.
Yeah, hey, well, at least you know that your toothache will go away.
Hopefully.
That's a good thing.
Bye, everybody.
All right, see ya. So virtual assistants, so we've got Google Now and Siri. These digital assistants rely on artificial intelligence, machine learning, and voice recognition technology to understand your conversation style voice commands, because people have different accents and different speaking styles. So you would need to teach your phone how to recognize your voice. So by pairing simple voice requests with other inputs like GPS location, some of these assistants can perform several tasks. They can play you a specific song, do a web search, take a note, or send an email. And this is going to become more and more common, which is a good thing, because I don't like to type on a phone. Do you? So methods for securing our mobile devices. How many of you have ever lost a phone or misplaced a phone? I'm sure lots of us, right? So we've
I
got,
accidentally dropped my phone.
yeah, well, yeah, most of us have done that. I like OtterBoxes just for that reason. So it's a good idea to secure your device with a passcode lock. And that gives you some more, that makes it so that it isn't always on, and at least you need a PIN or a passcode. If there's any biometric capability, then you should utilize that. In theory, a passcode like a PIN could really be guessed very easily given enough time and perseverance. So some of the steps you can take to protect yourself is to have your device locked down after failed logon attempts. Very similar to what you should do for your computer. Another thing that you could do is you could set it up to wipe the data after X number of failed logon attempts. The best way of dealing with failed logon attempts is to enable two-factor authentication, and that prevents some of the guesswork for sure. So different devices will lock data after a certain number of failed logon attempts. We can also do remote backups, and a remote backup is when a device copies its data to the cloud storage using a backup app. If the data needs to be restored, you can run the backup app and access the website to retrieve the data. This is particularly good if you have, if you're, getting a new phone and you're upgrading, and you don't want to redo everything. You can just back it up. And the way an enterprise will manage things is through mobile device management. So MDM, I want you to be familiar with that acronym, because there's a lot of MDM software that you can use on an enterprise environment to manage the cell phones that you are issuing to your employees. So locator applications. So both Android and iOS have apps for locating, remotely locating a device. If your GPS is turned off, it's probably not gonna be as easy. But you can probably go into your settings through your computer. I'm sure you can go into your Google settings through your Google account and change that, just like you could go into your Apple settings and change that. So if your device is misplaced or stolen, it's possible to find it using the Locator app. And it should be installed and configured on each mobile device before it's lost, because installing it after it's lost isn't going to do you any good, is it? There's also third-party software like Prey, P-R-E-Y. I'd mentioned that before. That's something that you can use for your laptops, your phones, all of your devices. So third-party software is good as well, but of course your start test won't be asking you about that. So remote lock and remote wipe. So if you realize that you've lost your phone, you can go into your Apple or your Google account and you can at least lock it up. And that way, if attempts to locate a device have failed, this would be one of the security features that can prevent the data from being compromised. And remote lock and remote wipe. For iOS, it's lost mode. For Android, it's lock or erase phone or erase for the wipe. And they both have similar security features. So you're basically trying to make sure that all of your data isn't out there in the wild. So you're using your phone to access the internet, right? And to do all kinds of things. You may share this, if you're using Chrome, you may be sharing the same bookmarks that you're sharing, that you're using on your laptop. So you want to make sure that this is secure, and make sure that you're running antivirus software, because it is very important. Anything that's going to the internet should have antivirus software. iOS doesn't allow automatic or scheduled scans, so you're going to make sure that you're going to have to do that yourself. And all of our mobile device apps should run in a sandbox, and that's going to keep it separate from the operating system, which does make it a little bit more difficult for your system to be compromised. So rooting and jailbreaking. Okay, so once upon a time, I wouldn't think twice about rooting my Android phone. Of course, once it was past the warranty period, because as much as I like the t-shirt, I avoid warranties for fun. Phones are expensive, and I would always make sure that I was past the warranty period. The main reason why I would do that is so that I could be root, and so that I could play with it and do things that I wanted to do to it. That was a long time ago. We use our phones to authenticate into so many apps and sites now, and you really run some serious security risks by breaking the secured sandbox environment on your phones now. I would strongly suggest that you don't root or jailbreak them. So rooting, of course, is Android, and jailbreaking would be for your iOS device. It does make your system way more vulnerable. So yeah, patching and updating our operating system. So just like the operating system on a desktop or a laptop, you can update or patch the operating system on mobile devices. Updates can add functionality or increase performance, or in the case of iPhone, could wear your battery down so you buy a new one. I'm sure that you guys must have heard about that update. They did make that right down the road, though. So patches, of course, also can fix any security problems or issues with any hardware or software. So you want to make sure that you keep your system up to date. There's also device radio firmware. So you've got your preferred roaming list, which can be changed so that you can make calls outside of your carrier, and your ISDN for your cell tower communications. So Linux and the MacOS operating systems, yay. So let's talk about all these different flavors of wonderful things. So we've got Unix, and it's a family of multitasking, multi-user computer operating systems. It derived from the original AT&T Unix The development started back in the 1970s with Bell Labs research, and that was by Ken Thompson and Dennis Ritchie and a bunch of other folks, and they really created an amazing operating system. Linux is a family of open source Unix-like operating systems based on the Linux kernel. An operating system kernel was first released in September 17th in 1991 by Linus Torvalds. He was a young guy that was studying computer science at the University of Helsinki. I thought it would be a good idea to have some sort of freely available academic version of Unix, and he promptly started to code one. From the start, it was his goal to have a free system that was completely compliant with the original Unix. And so that opened up the opportunity for an operating system to not be hardware dependent, because up until then it had been. It was written specifically for specific hardware. So Linux versions are typically packaged in Linux distributions or distros because Linux is open source. Users have complete control of the operating system. They can and have revised and created their own versions of Linux. There's hundreds and hundreds of distros of Linux, ranging from Ubuntu, easy workstations, to complex scientific distros. And let's not forget all the TVs and thermostats and embedded devices and IoT devices that are running Linux in one form or another. CSCI49 is an introduction to Linux, which is should be on your radar for next semester. And CSCI26 is Linux administration. So you aren't going to need CSCI26 unless you are going for the cybersecurity degree that we're working on, or that is coming up. So although macOS is BSD based, so it's not open source. Apple keeps strict control over the entire system, from hardware to operating system and applications. And that's why there are fewer issues with Mac devices, because they're in complete control of everything. I like to play. I like to be able to upgrade devices. And so that's, and I'm not fond of proprietary software. So that's why I would prefer to not go the route of Mac OS. We've got a Linux GUI. So the interesting thing with Linux is you don't need a graphical user interface for Linux. And the graphical user interface is actually called an X window. And the X window can be a number. You can choose the type of X window that you prefer. There's KDE, and there's GNOME. So there's a bunch, and Unity. There's a bunch of different desktop interfaces that you can use. You can lay on top of the operating system, but it isn't integrated into the operating system the same way perhaps it is in Windows, right? With Windows, if you don't have the graphical user interface, unless you're a wizard with PowerShell or command prompt, there are some things that you can't do without the GUI. So anyway, different Linux distros ship with different software packages, but your users are going to decide what stays in their system by installing or removing the packages. Ubuntu Linux is the most common beginner's version because it's the easiest to learn. It's really simple to install, and it uses Unity as its default GUI. In Linux, we call the GUI an X window, as I said. It's not necessary for the operating system to run. And Linux is, because it's based on Unix, it's designed to have multiple users logged on to and using the operating system simultaneously. So even though we say that Windows is a multi-user operating system, how difficult is it for two people to be logged into the same computer at the same time and do things simultaneously? Oops. It's very difficult, right? Even if you remote desktop to a Windows machine, the original desktop is unusable. So because of that multi-user capability, lots of people can log into a Linux machine simultaneously. And we also have the ability to have multiple desktops or workspaces and share that common environment. Here we've got an overview of the Mac OS, and there's some differences between older versions of Mac OS and Mac OS X and Mac OS, and with the addition of Aqua GUI. And so we've got mission control, and mission control basically allows you to organize your apps on multiple desktops. When you're navigating the file system, the Mac OS includes Finder, and it's similar to the Windows File Explorer. Screen sharing is also a feature that lets other people using Macs to be able to view your screen and even take control of your computer. So that would be your remote administration. And so here we've got our application programs, our shell, and our kernel. And basically all operating systems have a kernel to interact with the hardware. They have a shell to work as an intermediary between the user and the kernel, and software interface for applications. So when you're working from the command line, most commands or tools that have support parameters or options or switches. And with Linux and Mac OS, it's preceded with a dash character. And also in PowerShell, we precede our options and switches with a dash character. So although a command line interface is still present, the operating system often boots to the GUI by default, of course, hiding the command line interface from the user, because most users are not interested in the command line interface. One way to access the command line interface is through the terminal emulator application. And we would have terminal emulators in both Linux and Mac OS. And there's a number of different term emulators that you can use in Linux. Not so much in Mac. And basically, these applications allow user access to the command line interface, and they're often named as some variation of the word terminal. So looking at the terminal window, so when a user successfully logs into the system, the logon program is going to start the shell. And then an authorized user can begin interacting with the operating system through text-based commands. Everything in Linux is a file. So remember what we learned about our Windows machines and our Windows files, and that we have our extensions. We don't need extensions in Linux. We can have extensions so that it makes it easy to recognize if you're moving things from a Linux world to a Windows world. But it's not necessary to have a file extension. We can talk about the kernel, and it's responsible for allocating our CPU time and memory to processes. The kernel also manages the file system, communications in response to system calls. The Mac OS includes a terminal emulator called a terminal, but there's a number of third-party emulators available. And here, actually, let's look at that screen. Let's go back and look at that screen, because as we can see, somebody has done an ls-l, and we want to look at the documents directory. And so basically, we're listing all the files that are in the documents directory. So that's ls, means we're listing those documents. When we type the -l, that gives us the long information about those documents. It gives us the permissions, it gives us the owner, the group, how large the file is, when it was last, and a timestamp of when it was last modified, along with the name of the file, of course. Don't forget, in Linux and Mac OS, it is all case sensitive. So if I tried to do the ls-l with a lowercase d on my documents instead of a capital D, it would say that it couldn't find it. Of course, you're going to go into a lot of Linux information when you get into CSCI25. This is just giving you some of the basics that you're going to need to pass your certification test. So with backup and recovery, it's going to depend upon the distro. It may or may not have a backup tool included by default. If it doesn't, there's plenty of backup packages that are available to download. So it just depends on what distro and what comes with that distro. CentOS, for example, has a backup. I believe Ubuntu also has a backup package. So when we're talking about packages, those are our application. So when we're downloading software for Linux, you're going to use a package management system. And that's used to install, remove, store, and provide information about the software and resolve some dependencies. Different package managers will or will not resolve dependencies. So dependencies are the things that you need to put in place in order for the application to work, right? So we've got dpackage, which is Debian. It's a base package management system for the Debian Linux family. You could also use apt-get. And apt-get is actually preferred because it will resolve all dependencies. Dpackage doesn't resolve dependencies, but it can work directly with all .deb files. Also, apt-get invokes dpackage for low-level operations. Other relevant Debian tools are apt-cache and aptitude. Aptitude would be the GUI version of apt-get. So depending upon which branch of Linux you're using and which distro of Linux you're using, you will have access to different package managers. So for Red Hat, we've got the RPMs. That's the Red Hat package manager. For Fedora, we have Yum. For SUSE Linux, we could have YAST, RPM, or Zypper. For Arch Linux, we could use Pacman. For OpenSUSE, as I said, we can use Zypper. For Gentoo, we could use Portage. So because Linux is open source, we have lots of developers and lots of programmers out there making stuff that we can use. And a lot of times it's for free, which is very nice. So macOS. So with macOS, we have the Time Machine, and that users choose an external drive to be used as a backup destination device because it's kind of silly to back up your system on the same hard drive that it's stored in. Why would that be dumb? I mean, the whole reason why you're backing this up is to prevent hard drive failure. And if it's on the same drive, it's not going to do you much good. So you can connect to Time Machine either using if there's a USB by chance, or FireWire or Thunderbolt. And Time Machine will prepare the disk to receive backups, and when the disk is ready, it will perform the incremental backups periodically. So Time Machine is going to store some backups on your Mac. So if Time Machine backup disk is not available, you may be able to restore a backup directly from your Mac. And we've got a number of different disk utilities. So there's a bunch of them for Linux, for sure. Repair disk permission is a common troubleshooting step in macOS. Disk utility can also be used to back up disks to image files and perform image recovery to disk from image files. So some of the common maintenance tasks that can be performed using our disk utility software. So we've got partition management. So when you're working with computer disks, you may need to create, delete, or resize your partitions. So that's how you would do that. Mount or unmount disk partitions. So on Unix-like systems, mounting a partition relates to the process of binding a partition of a disk or an image file to a folder location. Disk format. So before a partition can be used by the user or the system, it has to be formatted with a file system. We talked about that last chapter. Bad sector check. When the disk sector is flagged as bad, it becomes harmless to the operating system because it will no longer be used to store the data. We don't have to worry about that as frequently with SSDs because it's not stored the same way. We can query our smart attributes, and smart can detect and report attributes about a disk's health. Smart attributes are really important. You need to enable that you can enable and access that from inside your BIOS, and it can tell you if your hard drive is unhealthy, and maybe it's a good time for you to consider getting a new hard drive. The goal of SMART basically is to anticipate the disk failure, and that allows you to move the data to a healthy disk before the failing disk becomes completely inaccessible. So that is a really good feature. And if you're having issues with corruption on your operating system, blue screens or whatever, once you've checked your RAM, I would strongly suggest that you check your smart features and run check disk if it's a magnetic hard drive. So schedule tasks. There's lots of scheduled tasks that you want to make sure that you perform frequently. And that way you can detect problems. To avoid missing maintenance tasks due to just being human, right? We can program our systems to perform the tasks automatically. And that's really what you want to do. You don't want to have a calendar that you're writing these things down on. You just want to have them run automatically. So as a service, cron runs in the background, and it executes tasks at specific dates and times. Cron uses a schedule table called a cron table, and it can be edited with a cron tab command. Operating system updates. So, while companies have update schedules, the release of, sometimes unscheduled operating system updates is common because perhaps there was a major vulnerability that was found in the operating system code. Firmware updates are usually held in non-volatile memory, such as ROM or flash. And don't forget, firmware is the type of software designed to provide low-level functionality for a device. So your BIOS, for example, is firmware. And so flashing your BIOS would be an example of a firmware update. Also, your wireless access points at home have firmware that should be updated and maintained. Our antivirus or anti-malware. So for our antivirus software, viruses change their signature frequently. And so you want definition files updated. So our DAT updates, basically the signatures or the signature files or files containing a sample of the code used by the viruses and malware. If you don't update your virus definition files, then you won't have the most recent version of viruses to look for. It's not going to look for things that it doesn't recognize. So since new malware is created and released every single day, the signature files of antivirus and anti-malware programs have to be updated just as frequently to make sure that they know what they're looking for. And security. So lots of security. If you're in the Security Plus class, or if you are planning on registering for the Security Plus class, it is on the schedule now, along with CSCI40. So please make sure that you sign up for that as well. And so security. So we've got, applications and other services can request and utilize credentials. So we've got our credentials. So our digital certificates, our passwords, our encryption keys, all those credentials are associated to the user. So we're going to have a security credential manager service. The security credential service on Ubuntu, that's what it's called. For GNOME, we have the Keyring, which is the security credentials manager for Ubuntu. And to access the GNOME Keyring on Ubuntu, you're going to click dash, search for key, click password and keys. And for the security service credentials on a MacOS, we've got a keychain, and that's the manager for macOS. And to access the keychain, you're going to go to Applications, Utilities, and then Keychain Access. So here we're back to Linux and some commands, so our CLI commands. ls-l is the most important command because it's going to show you what is inside of a directory. So here we're looking at a file that's listed using ls-l. So the permission is read, write, or execute. It defines how the user or group or other, we have user, group, or other. So we've got 3 RW, a space of 3 RWX, another space of 3 RWX, and another space of 3 RWX. And so we can determine what we're going to give our user, our group, or others. So permissions are quite easy to manage in Linux, not quite as convoluted as they are in Windows. So the user is the name of the owner. The group is the name of the group that owns the file. So whoever the owner, whatever group the owner belongs to. And other is anyone else. We've got our file size, which is showing the file size in bytes. We've got our date and time, and that's the timestamp. So that's the date and time of the last modification of the file. We've got our file name, which is the directory name. And as you notice, there is no extension on that file name. So it's not .doc or .text or anything. And here we've got an explanation of the directory permissions. So every file and directory on Unix systems carries its own permissions, and that defines the actions of the owner, the group, and others, and what they can do with the file or directory. So it can be either RWX, or there's also a value, a decimal or an octal or binary value that's equal to that permission. The only user who can override all file permissions in Unix is the root user. Root access is often required before performing maintenance and administrative tasks. So as we can see, there are a number of different options that we can do. We can have write only, we could have execute only, we could have no access, we could have read only, read and execute, or read, write, and execute. So there's lots of different things that we can do there. For our administrative commands, there's a number of different commands. Passwd allows users to change their passwords at the terminal. PS allows you to monitor your processes. Kill allows you to end processes, so you would kill whatever the process ID number was. ifconfig is similar to ipconfig, so except ifconfig gives you more information about your networking. Let's see. iwconfig is to check your wireless settings, and chmod allows you to change the permissions of files that you own. sudo, super user do, basically grants a user root access without changing their profile. So when you want to do something as an administrator, but you're logged in as a user, you can sudo to root and do that. Chown allows the user to switch both the user and the group of a file or files. apt-get is used to manage your software packages. Shutdown, of course, is used to reboot, halt, or reboot the system. And dd is used to copy files and partitions. Disk duplicate is a block level duplication process, and it's very effective. So you could technically boot, so if you have a corrupt Windows environment, you could boot from a Linux USB. You could DD the files that you want to get off of that Windows system and copy them and recover the data. Don't forget, that's your most important task, is protecting and recovering the data. The operating system will get corrupt at one point or another. That's another thing that I should probably mention is in the Windows environment, frequently it will not let you break the system. You know, it'll say, oh, you know, you have to be an administrator to do that, or oh, you don't have permission to do that. And even some system files an administrator cannot remove. Whereas in a Linux environment, you can remove critical system files and destroy the entire system. And it will not say, are you sure you want to do that? It will just let you do it. So troubleshooting. Hey, doesn't this look familiar? Here is our 6 steps of troubleshooting. Identify the problem. Establish your theory of probable cause. Test the theory to determine the cause. Quite possibly, you'll only get to step 3 and you'll fix the system. If you don't fix the system at step 3, then you're going to have to do more research, right? Establish a plan of action. Do more research. You know, Google solutions, check forums, other things like that. Step 5, verify that your system is working and implement preventative measures. So do some preventative maintenance. Try and reproduce the problem. Reboot the system over and over again. Make sure that your user agrees that yes, the system is fixed. And then document everything. And here are, you know, some of the questions that you're going to want to ask. You've got, of course, open-ended and closed-ended questions. And it doesn't matter if you're, you know, using Linux or macOS or Windows. You need to, you're going to be answering the same questions. So you're going to be using the same troubleshooting process. Particularly with your mobile devices, you want to know if it's still under warranty. And has it recently been updated? So establish a theory of probable cause. Of course, you know, ask your questions. Ask lots of questions of the user, you know. And test the theory. So quite possibly you may see, you know, what the problem is, and then you can fix it from there. So maybe you can force a running app to close. Restarting your mobile device. Quite frequently, our phones never get rebooted. So, you know, oh, the battery's running low, I'm going to plug it in, I'm going to plug it in. And so it's just as important to reboot your mobile device as it is your desktop device or your laptop. You can restore it from a backup. You can reset it to the factory defaults if it's so bad that you can't get any other functioning to work. So these are all very familiar steps. And of course, if you don't manage to fix it with step 3, then you're going to have to do some more research. So you're going to check your repair logs, ask other technicians. This would be when, if you're a tier 1 tech, this would be when perhaps you escalate it to a more knowledgeable technician. Check your manufacturer's FAQs, your technical websites, device manual, Reddit. Reddit's a good place to find out, to find useful information. You can verify your system functionality, so reboot it, browse the internet, make sure it's working, make sure that your carrier type is working so you can connect with 3G or 4G, make a phone call, set a time outage, different types to make sure it doesn't freeze up on you. And
breaking up again.
Pardon?
You were breaking up again.
Oh, okay. Sorry about that. Let me see.
You sound okay right now, but
I do? Okay.
yeah.
Because I see I have an exclamation point on my mic. So can you hear me okay? Is
Yeah.
that better? Okay. So make sure that that you tell your users, to verify that it's fixed. And of course, once you've done all of that, you're going to want to document everything. So document, discuss what the solution was. If it was just turning it off and turning it back on again, make sure that you tell your user that it's important to do that every now and then. Because a lot of times we just put it into sleep mode or just plug it back into the wall and it never gets turned off. Verify that the problem's been fixed and document how much time it took and the steps that you took. And a lot of times you're going to have your user sign something like that. So there's a whole bunch of common problems and solutions. Please go over that list. It's extensive and it can really help you out as you're learning the troubleshooting flow chart. So lots of different problems and solutions, and I believe this is one of the chapter activities. So please make sure that you get that done. It's so nice to have something that's going to show you, oh, this is what it is. How lovely. So we've gone over an awful lot. We've talked about our mobile operating systems, iOS and Android. We don't have to talk about Windows Phone anymore because that's gone away. We've got different methods for securing mobile devices. Oh, on that Windows Phone thing, don't hold your breath because I bet it's going to come back in the next 10 years. And we talked about the purpose and characteristics of Mac and Linux operating systems, the different flavors of Linux operating systems. And you'll be learning a lot more about Linux when you get into CSCI49. And how to troubleshoot other operating systems. So we're using the same troubleshooting tools